Although this video is to go over the 9.4.1 core questions where we're going to be dealing with the system of inequalities. Remember from earlier chapters, we did linear inequality or linear systems, and you had to solve it by using substitution, elimination, or equal value. Well, when you solve a system of inequalities, what you're going to do is you're going to graph them, and you're going to find a region which they all have common coordinate point solutions. So in this first example, we would graph it like we did last week. So I'm going to ignore the inequality sign right now and just graph y equals negative x plus 5. So I'm going to start at positive 5 for my y-intercept, and my slope being negative 1 is I'm going to go down 1 over 1. As you can see on my graph, I'm coming by 1s. Now, because this has an equal sign, this would be a solid line. So I'm just going to go ahead and connect my dots going this way. So that's the first inequality. I'm going to worry about shading it in a second. The second inequality, it starts at negative 1 for my y-intercept. I'm going to go slope of 2/3. I'm going to go up 2 and over 3, up 1, 2, and over 3. And now this one does not have an equal sign. So this would be a dashed line. So after graphing these two linear inequalities, you can see that I have basically 4 areas in which I could shade. I could shade this, 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 or this. So if I look at the inequality though, it says y is less than. So I probably want to shade below the line. So I'm just going to do like little arrows here to show it's probably going to be somewhere shaded this way. If I look at this one, this is y is greater than. So it's probably going to be above the line. So the arrows this way. And if you look at right here in this area, because the arrows are going this way and this way, so this would be the common solution region. So anything, again, these lines go on forever and ever, anything in this area would be a solution. So I'm going to choose a point, for example. So if I chose negative 2, 2, and I put negative 2 in for x, that would be 7, and 2 is definitely less than 7, so it works. I put negative 2 down here, I would have 2 is definitely greater than, and this is going to be a negative number. So again, everything in here shades. Now, if I would have chosen a coordinate point in any of these other areas, it would not make both equations true. It has to make both inequalities true. So again, that's how that works. So the next example is question number 90, where again, we're going to graph the two inequalities. So I have a y-intercept of +2, and my slope is 1, so up 1 over 1. And again, if I look at the inequality sign, there is no equal sign. So this has to be a dashed line. So if I look at this, because it's less than, if I want to shade below, so I'm going to go this way with my little arrows. I'm not going to shade a lot, just to kind of remember that. But I can also prove it if I put in 0, 0, which is below the line. 0 is less than 2, so that would definitely be where I would shade it anyways. Now if I graph this next one, I'm going to start at positive 10 for my y-intercept. I'm going down 3 and over 4. I go down 3, 1, 2, 3, and over 4 one more time. This helps me with, I'm trying to freehand this. So it has an equal sign in my inequality, so I want to make this a solid line. And then what you would do is, it says it's less than this, so again I probably shade below the line. And again to check, because 0, 0 is down here below my line, if I put in 0, 0 is less than 10, because that would go with putting a 0 for x. So now you can see the arrows are going below this line and below this line, so the only area they have in common would be this area right here. So anything, again, this goes on forever and ever, but anything in this region, all these coordinate points, would make those inequalities true. The next and last question I'm going to talk about with the core are questions 91 and 92. They're related, and instead of doing the graph, I'm assuming you can graph at this point. So I just made the parabola. It's a solid parabola because it has an equal sign in the question, and this one does not have an equal sign. That's why it's a dashed line. So if I'm going to solve this system, I want to shade, and again, this has quite a few areas to shade. I could shade in here, above here, on these sides, or below it. So what I want to do is I want to choose the parabola here. It has to be less than, so it would be everything below the parabola would be which way I would shade it. If I look at the line, it's everything above it. So everything below the parabola and above the line would be in these two areas right here. I'm just going to extend this parabola so you can see that. So it would be everything kind of in these areas above the line and below the parabola they have in common. So what they try to do in question number 92 here is they use the same exact equations, but now they change the symbols. So now this is y is greater than, so it's going to be everything inside the parabola because it's above the parabola, and everything greater than the line. So things that are inside the parabola and above the line would just be this area right in here. So again, inside the parabola and above the line because they're both greater than. And again, to check, you could choose any coordinate point in this area and plug it in for x and y, and it would make it true. My next example is it's greater than the parabola, so it's everything inside the parabola, but now it's less than the line. So it would only be this little area right in here where it's less than the line and greater than or inside the parabola. And again, if you chose any coordinate point in that shaded area, it make both of those true. And then our last combination, they're both less than. So it'd be below the parabola and below the line. So it'd be everything in this area right here only. And again, that's how you would solve inequalities, whether they're linear or nonlinear. You graph them first, make sure if it's a solid or dashed line, and then you shade the areas in which all the coordinate points make sense. And again, one pattern within inequalities is if it's ever greater than, it's typically you shade above whatever the thing is. In this case, it's linear for this one. And if it's less than, you usually shade below. And you can check that.